And it's a good thing we checked because I hadn't powered on the microphone unit. Okay, sounds good. We are ready. I guess I should post that in the Discord. Okay. So the announcement's gone out. Stream has started, the audio's been checked, and my sons are being quite loud. Okay. So we are ready to begin. Welcome to the stream of the Discourager of Hesitancy. Today, we're hopefully going to wrap up settings for the time being. We have a thing we need to do with volume, and that's going to also involve trying to linearize the volume control, which we will talk about shortly. If we get that all done, we are going to write out and read back the settings so that when you close and open the program, it is saved between runs of the program, which will be nice. I think that's the plan. If we get past that, we have plenty of loose ends we can tackle as well. So, time to get the beverage of choice ready for the stream and see if anybody notices the notifications and wanders in. Yeah, so one of the purposes of this stream was to show that programming, even on something as interesting and cool as games, is often a bit of a slog, and that the ones that can make it are people who can press on even after it's become boring, right? Actually, interesting anecdote, although nobody's here to listen to it. So maybe we'll hold off on that thought until later, some other time. Okay. Okay. Let's head over to the journal. Today is the 17th. Wow. Time flies, right? What are we working on today? We are stealing this task. Settings. Okay. No, I don't know. Maybe that's more of a text label than a gameplay. What else do we need? That's warm. Whew. I may have overheated my water. Never want to burn my water. So here's the plan with volume. Human ear does not respond linearly to audio at a volume. So if we take a sine wave from 1 to -1, and we call that full volume, right? And then we scale it down for half volume, cut it in half, so it's from 0.5 to -0.5. That does not sound the same volume to us as if we scale it down to a quarter, right? So if you cut it in half again, it doesn't sound like a quarter. It is I believe it's a logarithmic curve, which we can probably check. Human ear volume sensitivity curve. Let's see what that comes up with. Equal loudness contour. Oh my goodness. Fletcher-Munson curves. So let's see, this is some crazy stuff. Maybe we show this. Is it not coming up? Because this one, interesting. Okay, well, I'm being defeated by OBS. Really? I can't show. This worked once. I know it did. They're so loud. Okay, sounds like somebody's getting doctored up right across the hall. I may close my door today. This is getting really bad. That might not make much of a difference. We'll see. Turns out the doors don't actually hold out much of the noise. So why? Oh, no, not that one. Okay, I don't know why. I can't get my browser to pop up on OBS. It is, well, unless it thinks it needs to have the same title. Okay, I give up. Anyway, but yeah, the curve of what humans can perceive is not according to the numbers. It's not linear. So we're going to take three things into account. Each sound that I have has a different audio, different perceived volume because of the way it was recorded. So each of those will be scaled individually. Each sound will have its own volume. Then each sound will belong to a group or have a tag, I guess. And that tag will be something like gameplay or music, or in the future it might be something like voice, or ambient sounds, right? And they'll have a tag, and that tag will have a volume associated with it, and then there will be a master volume where you can turn the whole game up or down as you will. And hopefully when we combine those three parameters, right, the master volume, your tagged volume, and your individual audio volume, we can get all the sounds to roughly balance in an okay manner. So, good luck us. So let's dive into it. We're gonna be in the settings scene. We will need 3 things. We need an IntSpinBox for master volume. Music volume. And I guess game volume? Sound effects? What's a good... I'm trying to remember if there's been like a game menu that I thought labeled it well. Let's see here. Another name for game sounds. Sound effects, game audio, sound effects. Because what we have are the game sounds of like the tick 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 when a word is guessed. So we just call it sound effects, SFX. Then, you know, in obviously future games we can have other tags, right? Like voice. We don't now, but that's fine. I think those are our 3, which means sounds. Well, we're not gonna worry about that. Just gonna get these in there. And let's take a look at our layout and decide what we're doing here. We bring the game up. Go to settings. We need 3 volumes right here. Like this is the general graphics and audio stuff. This is the very game specific stuff. So if I put a label and then a spin box, label, spin box, label, spin box. Obviously we need to add art to distinguish the different regions a little bit. Put like each of these in a panel. Let's just go label, spin box, label, spin box, label, spin box. Label for master volume. Music volume. We don't have any music yet, so we may have to fake some music. Sure. Label for SFX. We want a label for just the overall volume. Might as well. That's easy enough. So we'll have a big label, then 3 small labels. So let's get them in at least visible. Are these ones? volume, master, music, sound effects. Okay, well, we'll try it. Volume, master volume, music volume, sound effects volume. Spinbox, we set callbacks. Hmm. Okay. The whole Spinbox thing will have to come in here eventually. But in the meantime, on update, on render, over here is the gameplay general. Grab our render. So they will show up. So we should probably do a little bit of layout work there. One where we set the size, so underscore label volume. It's that one. So we're probably going with small button font size then. Okay, so there's the sizes. Okay. So this is the most likely thing we're going to see. Label volume. Set rectangle x2 y. We'll make it big. Yeah. Label master volume. Will be at x2. So we'll have an indent. It'll be at the new y. It will be small button width, small button height. That's not the right line at all. Okay, master music and SFX. So that lays out the labels. Except here, small label width. That's probably what I actually want down here. Okay, so here's what has to happen. We go down Y, then we this happens at X and Y. It's this wide. Small label width. It's a small space. the master volume. Am I making sense to myself? So we throw down the volume, and then we move over. And then we move SpinBox master volume, which then goes down, and X has to be reset here. I think this is the pattern we need. So we will just change master to music everywhere that matters. Master to SFX. And line it all up. Oops. We just want to see how our layout looks. So, do our first build of the day. Sorry about the late start today. Just the way it works out sometimes. Maybe we'll go a little long today. We'll see. Okay, well, that's not quite right. I think we copied the X1 over. So that's definitely wrong. What if we swap volume and screen size areas? But we'll get to that. All right, so let's go in here and fix this. It's not X1, it's X2. X2, X2. That's what happens when you copy paste. Okay. Okay. So there's our volume controls. That looks like things aren't lining up the way I want. Let's see. Straight edge. Oh, curious. So the selected screen size and these buttons don't line up the way I want. Also, there's enough space between this area and this area. We could shrink it. We do need to shrink this text area though. Master, music, SFX. Lines up. Okay. So one thing we want to do is here. Set range from 0 to 10. We do not go to 11 yet. That's not a thing. We're going to set value on each of these, which we need to get from game context. So we need a game context to contain master volume this is a bounded value, so let's just get in there. Music SFX. We're going to make them private. Static members. Equals 10 equals 10 equals 10. Okay. Then we'll need some accessors and setters for it. Music SFX, as well as static int master volume music and sound effects. Like I said, it's trivial to add more channels later, so I'm not concerned with that at all. Then by the magic of macros, we stub them all out. Again, by the power of macros, we get that done pretty quick. Here, it's going to be a little bit more complicated. We want to say if volume is less than 0, volume equals 0, if volume greater than 10, volume equals 10. So we just clamp the value. Then equals volume. There we go, easy. Now in settings, set value equal to the value from game context. Did I call it? Yeah. Music volume. Music volume. SFX. SFX. Okay. I think that should do that. So we should now get our range from our game context. And it doesn't blow up, and they are indeed 10. That looks okay. This misalignment and this caret starting to... Are they annoying me or what? Are they annoying me? They're kind of annoying. This isn't that bad. Okay. That's fine. We're already... Well, okay. Do I want to fix these buttons? What's their offset, and why is that different? So we were doing these ones. Okay, so this should be big button height offset. Except here, X plus the small button height. Do just replace this with the same thing but small button height. That probably gets us the most consistent layout, but then the small button width is 75. Also, where is the label for the selected? Where's that layout done? Oh, probably in... Instead of center left, I want center right. No, that has to be left. So which one has chosen resolution? Which is center, center. We'll make it center right. There it's rendered. And here it's laid out. Who is setting this guy's rectangle? There it is. Small button height, small button height. Okay. I think that's going to work out better for us. I think so. In terms of aligning my layout here. Much better. Okay, more consistent. I don't know that we want that all the way up to the edge. Oh, also this width. So maybe we add a spacing to it. X1 only indented by the small button height. X2. And maybe we go back to center for that one. Okay. Now, not the button. We need a spin box callback. There we are. Inbox master volume. This thing. Game context. We don't even need this to actually be a pointer. We can literally just give it clean context set master volume. Maybe we have to put a pointer address on it, but not a pointer address. Address operator on it. Jeez. Okay. Take it for a test drive. So what should happen is we can set this to unique things like 7, 5, and 3, the first 3 non-trivial primes. When we go back, we come back in, it still gets those same values from the game context. So these are being correctly persisted, and that's good. So as far as settings goes, that's done. Now the hard part begins, where we try to. Oh, that's not done. That's not done. We need a button. We need a button. We need to be able to play a sound sample at that volume. Let me think about that for a second. Now I don't have any music, so I'll have to think about. Let's see if I can find a royalty-free song in WAV format. melodyloops.com, freestockmusic.com, free sound. That is terrible. Let's see here. Let's try something else. Let's see here. Corporate music zone. That always sounds super delightful. Yikes. Oh, here we go. Some Chopin. Little Chopin. That's not the kind of thing I want. Let's see. Labyrinthine melodic ambient track. Although freesound.org does look like it may have some very good, an awful lot of sounds. Oh, except you need classical licenses for, or commercial licenses for some of this stuff. Shoot. Okay, well. What to do? Free download MP3. Credit the artist. Like, ugh. No, maybe we don't worry about it just yet. Okay. Let's add some buttons to it real quick. M underscore. Do I want. I just have one button, one for the master volume, and it will eventually play both a music and I do have a thing which I might not be able to access from this account. Well, maybe I can. Let me go do a little digging. I might have a sort of song, like more of a like 12-second jingle. Might be okay for this. If I remember where I put it. Branding. Maybe it's in here. Oh, forgot about that whole side project. Okay. Here. I'm gonna see if I can listen to a couple of these real quick. So these ones I know are perfectly legal because my sister composed them for me. That's not bad. Maybe we'll go with that one. Just for the comparison in the settings until we get real sound in on, or real songs in. Okay, so we're gonna copy this song. We're gonna paste it. Placeholder song. Now we're gonna put it inside of our project real quick. I know you can't see this, but honestly, it's not that interesting. Otherwise, I'd waste more of my time trying to do all the OBS stuff to get it to show. All I'm doing is copying a sound file over. Projects, word sleuth, assets, sounds. Okay, we're putting in placeholder sound. Now we can edit this song.wav. Oh, yeah, sure. Song.wav. That's good enough. Assets, sounds, placeholder, song.wav. Okay. So in theory, if we run a full clean and build, setting scene is probably going to fail because I have not finished putting in the buttons. I just want to make sure that the sound bakes in okay. Do I list the songs? There we are. Placeholder song, 15 seconds, and it says it was okay without any error messages. So hopefully that this code here, this embedding the wave files, is not very hardened. So like if I get a wave file format that's encoded differently or has a different sample rate, I don't really do anything about that right now. So we'll find out if we're okay or not. Okay. Okay, so that did compile. Oh, I'm gonna hate seeing what that does to my code line count. All right, image score, volume test, volume check. I don't suppose there's a good ASCII character for this, and I'm not doing image-based buttons yet. That is on the list. Let's look at our ASCII characters. Maybe there's something that would make sense. In the printable range, printable characters. Just put a asterisk in there. Call it good. Or tilde. Tilde. There we go. Yeah, there's a good. Sure. Okay, so volume check is a button. I don't think there's anything I need to do here right now. We'll add a callback later. But where we set size of things, this is where it matters. This guy is going to be next to master. Plus equals spin box width plus a small space. Underscore button volume check. Small button width or small button height. Small button height. We'll just make it a square button. And then it increments y. X gets reset here. Okay. So the buttons don't have to be set to callback yet. Update. Here we are. Underscore button volume check. Render, etc., etc. And it will start, in theory, 2 sounds. Fortunately, I'm not an audio engineer. Probably there are known techniques for tools to make all of this much easier to balance out your audio. But we're not going to do it that way. We're just going to do math and brute force our way through it. It'll be great fun. Because that's how you learn, by doing things yourself. Once you've done it yourself, then somebody comes in and says, oh, well, here's a better way to do it. Then you're like, ah, I understand why that is better. I understand, like, you just know what's going on a lot more clearly, I think. Oh, can't type. Okay, that shouldn't take long. So just adding that one song is gonna like completely balloon out my audio, my memory, both on the executable and my code lines. But we're not gonna look at that until the end of the week, so it'll be a nice surprise. All right, so build this, run it. Settings, there is a button there, and we know what it means. Let's hook it up to something. Let's at least log. Well, we can. So here's a question. Action. So did I have it? It will not. The actions and the scheduler will not automatically create a sound object for me that only lives for the duration of the animation of this action sequence. So I will have to make a sound object myself. Let's set a callback. Underscore button volume check. Set callback. I guess we need one. Oh. Void volume check. I log way more than I need right now. 0.3f. 0.3f. Because here's one thought. Game context, master volume. Game context will be multiplied by music volume. Game context SFX volume. And then the question is, when we combine them, what happens? So ideally, what would happen would be something like game context, music volume, times game context, master volume. And we would switch these around for nice alignment. And then that whole thing divided by 100.0. So if I took each 0 to 10 and divided it by 10, then I'd get a range from 0 to 1. But if I'm multiplying two numbers that are between 1 and 10, then it scales to 100. It's the same thing. Then we do the same thing, but with SFX volume. So this will be what just the straight math says we should do, right? We just multiply them together. We put in different values and see what happens. I don't think that's what we'll be able to do. I think what we're going to have to do is round to the nearest half volume and then look it up in a table of 20 entries. That's what I think. I may be wrong. Well, that's awkward. Okay. STD bind. Settings scene. Okay, wow. Volume check. This. I guess you don't have to bind it. We could have just done a lambda function. I think we looked it up and the lambda function is faster than a bind. But it's been a while since I've looked at it, so now I can't remember. So if we go click, then our master times music. So master times music will be 1. Master times sound effects will be 1. Come over here and we say, oh, master volume is 7. And we want the music down low. Test. 7 master, 3 music, 8 gameplay, 0.21, 0.56. Yep. So math checks out as far as that goes. Which means the last thing to, not the last thing to do, but the next thing to do is to actually play a sound. or 2. So in game scene, we have some sounds in here. One of the most important ones is the click sound, and the number of letters that match in the guess. So I think we'll grab that one. Then we'll make one for song. There's the click sound we use. m_song sound. We'll get our song.wav. I think that's what we called it in here. Yeah, song.wave. So those should both load up. And then here, what we're going to do is we need, let's go to game scene. m_click sound. So the click sound is already being scaled down quite a bit from the raw, which we won't have to do as much once we get volume controls. Like these are basically manual values I picked. So these will scale as much towards 1 as we can get in the future. Then you would use your sound system, the volume controls to scale it down. But it's clear that the click needs to be a lot louder than these other sounds overall. So if we go into somewhere, volume check, there we go. I'm going to go ahead and make the song quite a bit quieter at this point, just so we can hear. Maybe like 1, 2, 5. Okay. Then the other thing we wanted to know is this action sequence. So basically, this will be the thing that plays the sounds. So we're going to make our sound sequence. Scheduler, there it is. Let's go with 5. The first one will be a little different. Oh wait, we can go 0 to 4, that's fine. Set start sound. We want the game sounds to overlap the music sounds. And I actually want, I think, to have a pause so that the music has time to build. what was it, 5? So let's go 6. Set weight for like 5 seconds. This sound, the song is gonna build slowly. What if we double this up? 4. Six. Okay, so we had 5, which was 4 and 1. We want to add a weight, and 3 more. So 1, 2, 5, 6, 7, 8, 9, 10. So go 5 and then like 7. Oh no, like 2. It's like 15 seconds long. And basically do this again for 3 more. We can also just make this more consistent, like this. Okay, so it's going to come in, make a sequence of 10 things. We're going to start the music. We're going to wait for this 5 seconds for the music to build. We're going to play tick, 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 tick 4 times. Then we're going to wait for 2 more seconds. Then we're going to play 3 more ticks. Okay, we need 2 more elements here. We have a disable button thing, but we can change the callback. Button volume check, set callback. Immediate. After this, we do nothing other than set callback. Semicolon, brace, and there. And after all of this is done, then we can enable the volume check. Again, this is not ideal. Like, I'm definitely don't want to do it this way. We're just hashing things together now. So once you click the button, it disables its own callback, then re-enables it when everything else is done. And that way we also can't kick off a second action sequence and have them queued up behind each other or overlapping each other, fighting for control of the sounds. Alright, let's see if it even does anything useful here. Oh gosh. All the errors. Oh, set immediate. I know it's wrong. The action index. We have to tell it which action to do this in. Action index was not declared, was it? That is true. Action index was not declared. Here's one question. Is it clever enough to change the audio mid audio stream. I think it is. So while the sound is playing, we should be able to try it out. And there it crashes, but it's probably because we added some things to our class layout. So now look, it's going to fail because of some bold artifact. So if we get all these controls hooked up in like an hour, which we're close to getting, we could easily spend an hour playing with the volume, perceived versus the other. Good heavens. Because that's one thing I've noticed, like, you'll drag the slider down and things will get quieter, and then like towards the bottom, like eighth of it, like I'm like, I want it just a little quieter, but there's like no resolution out of that. It's either it sounds the same, it sounds the same, it sounds the same, it's gone, or you know, I just can't get the level of quietness I want on a lot of things, because you know, like the music for a lot of games, I just kind of want it barely even there. But there's not that resolution at that low end. Oop. There we go. Okay, I don't no promises on your headphones. Check your ears. Here we go. Okay. So these are the sounds as manually tuned. So I need to find my quietest sound and ramp that all the way up to 1. Like each sound has its own volume, right? Oh, I should have tested what happens if I click the button again. Make sure that it does what I think it does. Shouldn't do anything, shouldn't do anything. Oh. It started that volume check before the sound finished. Okay, so we can make one more small change to this. We add 13 sound sequence when you set set do until. There we go. On the action index plus, and what it's going to do is nothing until I'm going to score sound song or song sound dot is not is playing. There we go. Now I won't be able to start the next sound until that sound finishes. So what is my quietest sound? Because I need each sound to have its baseline relative to the other sounds. So if I play any 2 sounds, they sound roughly equivalent. So let's build this and test it real quick. hit this button, I should not see that turn up to the console until the song itself is over. Interesting. Anyway, that's close enough for now. What we need is to do two things. We could go through each sound. Okay, so here's an idea. In here, we say, here's the file. Here's what I want to call it in the game when I'm requesting it. We could add a third column called nominal volume or something. So each of these files, when they're embedded, stores their preferred volume. Let me think about that for a second. All right, I'm going to go use a restroom, I think, while we think about it. Okay, back we are. Sorry, I just went out and grabbed a snack while I was out there. So, I'm pretty sure in About Scene, I made it so I can play almost any sound. So, this list should match with this list. Yes. So that is 14 sounds. Yeah, here we manually set the volume. So the best way to do this, you know what we should do? What we should do is add volume controls to settings, apply volume controls to sounds. So this is done. Volume controls been added to settings. Sounds not yet affected. We should save our work. Status git add. Oh, we did. We added things to the sound warehouse. We made it bigger because we added this song. Settings, scene, sounds, text. Yeah, so we just add everything. Okay, so before we can linearize our sound, we first need to know we need to apply the volume controls to a sound. So if we go to sound, class tag, and we said that there are music, sound effects, and I guess none. Oh, so that's an interesting idea too. We could set the tag in our sounds input file. Okay, so we need to tag. That's not really part of settings. Tag sounds and scaled volume per sound in embed sounds. Yes. In fact, maybe we do that first, because then we can have the sounds already tagged. I don't have to manually do it. And they can be all scaled to 1, and then we'll linearize it later. I think that's what we're going to do. Okay. So, while we We're going to tag them and apply a volume by default. Okay, so in assets, sounds main, no. Oh, tools. Bed waves. Okay. We're going to read in this key value file, which reads in pairs of strings, which is that okay? Wait, it'll now be 4 strings. So that is not something defined locally. So we'll have to change that and make it our own. It's in common, the common amount of code we wrote. It's a little pepper jacks, summer sausage. Be delicious. This must be the habanero jack, not the pepper jack with the jalapenos. Much of this has to go away. For now. Read chunk. Read formats. This is all about processing. Okay. Key value file. This is now moving beyond key values. sounds file. Read sound file. There we go. All right, this is not quite true anymore. Let's see. We want the file, tag, then we want the volume. Then I think I want emplace std vector emplace back. New element is constructed in place using args. So in theory, I should be able to use a struct literal of sound definition given key file tag volume. These are probably semicolons. Key file tag volume. Key file tag volume. Oh, for Pete's sake. sound definition. I don't need to worry about this. That assertion goes away. Oh. Okay, that's probably fine. Except I want the key, then the tag, then the volume. Yes, no, let's go volume, then tag, then. No, key tag volume. Okay, we're gonna try that. So go into sounds.text. Key, the tag will be SFX. So let's see. Volume will be 10. Music. Now they've all been tagged and given a number. So over here, I don't care about that. Red key value file. For sound definition, sound in the result. Const reference. Modulus S. Modulus D. So smd dot cstring sound dot key dot cstring sound dot volume and then sound dot tag dot cstring. So we're going to read it all in, and it should print it all out and return it. Move this out of here into here. All right. See how that goes. Oh, okay. Embed Wabs is not happy with me. File name is not declared in this scope. Line 40. Oh, well. Do that here. result is not declared. Oh, oh. That makes sense. It's not called result, it's called files. I don't remember what's even in this makefile here. The address of volume. Primary. Oh, it's commas. It needs commas. Comma, comma, comma. Now it probably wants the sound definition cast back in. It does not need this last comma. ISO C forbids compound literals. Why? Ugh. Jeez. Name. Sound definition F equals that. Pushback. I think that is dumb, but sure they have their reasons. Result dot length. And it's probably size. Okay, so that ran. For some reason I did that. Okay. Let's see, tools. Let's see. Let's look at the main make file here. When we cd into the tools directory, we go to the tools directory. Then we make, then we do this. So we do cd into tools bin. Embed waves. Okay, so there's the key, there's the volume, there's the tag, and it seems to be working. Okay. So we're reading in our file. The trick now is we need to write out a more complicated header and code file for when we embed this data. write out a header, but it's the default binary header, which is just key, data buffer, and nothing else. What we're doing is, well, I guess we gotta steal it. How much I'm able to essentially duplicate code. I don't think only state in the world. Get data, get size, get width, get height. So there's the key, there's the index data, and the size of the thing at the index. Privately, there's more stuff. so privately entries int underscore tags int underscore volumes. Tags and volumes. I think that's not all we need to get here. All right. Int get tag get volume. I think that's it for sounds in terms of the header. No. Obviously, we need this to be in the top declared somewhere. Actually, I guess we don't. Okay. So these came after get data or get size. Getting it from m underscore entries, we just get tags and volumes at index. I think that's it. I think that would write everything we need just fine. Except that's not quite true, because we do need to populate it. So somewhere in here, there's the name maps. That should be fine. File contents. Oh. Oh man. Maybe we should make it a float. We'll make it a float. So this right header does not need any information from that vector files. All it needs to know is the sizes of things. So this thing, take a vector of sound definition file. Okay. The first thing is the key. So definition.key index. Oh, so we do need the index. Yep. Go through each sound definition. We get the key and we get the index. So that we can use the name to look up the index. That makes sense. This place, we get the index, and this is oh, whether it's a comma or not. Output file string new line. Okay, that makes sense. So files at index dot key. Set the index to key map. Yep. Okay. Next place. File size is now the number of files. Okay. Dot. Now I don't remember. File. There we go. Key file name something else. Oh, we'll have to make a couple of changes. Okay. Key file name tag. We kind of don't need this anymore, do we? Yeah, that's fine. If we output a function, we're not dividing x by 2 right now. The function is going to need more information. It needs to know the tag and the volume, so that's going to have to change. Name, key, tag, volume. So that's going to complain. Okay, so this function being passed in is not this. Oh, hey, somebody showed up. Cool. All right. So we have file name key tag with int tag and float volume. Its function tag. Okay. The other thing we need to do is give these a size 10, 24. There we go. Oh no, wait. These are std strings. So that's fine, I guess. But you need int tag and volume. So invoke, where we invoke it, tag string. Actually, let's do it this way. Int tag equals 0 if the tag string equals something we know, tag equals 1, else if this equals something else, so in sound h, we use music and sfx. Oop. Oh, for Pete's sake. Music is 1, sfx is 2. Otherwise, we default to 0. Now, when we pass in tag, it's the integer we want and that volume we want. Sounds.text. Want full volume. Did I make them float up here? I did not. Float volumes. Okay. Save sizes. Which is here. We got basically sizes. So I want tags then volumes. Save entry volumes. TCAP. Oh, is my volume low? Sorry about that. Hello, hello. Turn it up a bit. There we go. Welcome aboard, TCAP. How's it going? Hopefully the volume's a little better. Maybe if I turn my mic a little bit. Let's see how that works out. Where did that temp size come from? Where did sizes come from? Okay. I see. Sizes, output entry sizes. Output entry tags. Output entry volumes. There we are. Okay, so what we're doing is we're changing the information we're embedding about a sound today to include a volume factor, I guess. So if you assume that all sounds come in with volume 1, well, some sounds are going to sound very loud naturally, and other ones are going to sound very quiet naturally. So we're going to, from the embedded data itself, store a leveling factor. Once that's done, we're going to then compare each of the sounds and try to make the quietest sound a 1, and everything else have a factor down from that to make them sound roughly equivalent. And once that's done, we then need to apply our master volume and either, and then the individual tag volume to that sound. So that's the goal today. Heyo, rating. Welcome aboard, strangers. How's it going? Why is everyone staring? No idea. Stare, 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 stare. Hello. Well, welcome aboard. I'm not sure why everyone's staring. Is it because I was staring at my screen? What kind of fame are you making? Game. Oh, game. Okay, let's do this. Let's go to the game and demo it since we have a raid going on. It's a word deduction game. People say it's like Wordle, but actually I'm copying liberally from a game from 1990 called Word Breaker. So it's an homage. It also limits my scope while I build up my tool set. So a lot of people have a problem when they make a game of starting with too big of a project, like Amazon, for example. So this is a very small game. 7 TV emote in case you don't see it. Nope. Okay, cool. All right, so let's run our debug build. Hopefully it's still in a working state. Today last couple of days we've been working on settings, things that you can edit about the game. But there are 3 play modes. One is marathon, how many words in a row can you deduce? Sprint mode, how much time does it take you to get 6 guesses in a row? And golf mode, get 9 words and the lowest number of guesses possible. So if we go to sprint mode and hit play, apologize for the beyond crappy developer art, but this is where we are. And then when you start typing, the timer starts. So we're going to guess prime lunch toads. And because these are 15 unique letters and there are 5 letters in the answer and there are no duplicates allowed, it means that we know that any letter that's not in those 15 can go away. Ultra demon, laced rhino, proud lines. Oh, not a lot of deductive material here. Beady, Okay, EAD has 2, so L and C have 1. Yeah, you want to do Amazon as your second project for sure. Well, I'm talking about Amazon's game studio, right? First thing they wanted to do was create the World of Warcraft build, breaker. World of Warcraft was Blizzard's like 6th game or something, and they had failures along the way. So when you start something new, you should start small because it's a learning opportunity, and B, you're yeah. Oh, you want to do Amazon as your second project? Yes, agreed. So part of the goal of this game is I want minimum dependencies, no game engine. So this is it. This is my list of dependencies. GLFW, glue, they came in together. They give me the OpenGL. And then I include GLM, which in my second game I think I'll get rid of. GL Math. I don't think I need as much as it's providing. And then free type is my font renderer, and port audio is my audio. Everything else I'm writing from scratch. So the second game I make, I'll have a whole bunch of these tools built up, and then it'll be a more ambitious game. Maybe by the third one we'll do the I don't even remember what Amazon's game was called. Amazon's game. What was it called? Of course, this is not helpful. It's the one where you're a conquistador, basically. MMO. Wow, this is like the least helpful Google thing anyways. Anyway. New World, that was it, thank you, yes. So, there's kind of a multiple purposes for this streaming, I guess. One, it keeps me focused. I don't go like watch YouTube videos all day. Instead, I get some work done. I have to be focused while people are watching. The other one is so that my nephews, if they ever decide they actually want to watch the stream, will learn that programming is largely a grind. So today we're grinding. We should probably finish up this deduction though. Logs usually doesn't give me much information. Oh, it does. So we can get rid of L, O, and S. That's good information. Opals is also, so I can have some shortcuts for things like this. E and D are in. I and N have to be out. M has to be out. T has to be out. R has to be in, and U and C. Everything else is out. So there's my word. So we can do like crude, cured. Oh, I guess it was cured and not crude. Then it picks a new word, and you have less guesses. So that's the game. What we've been doing last couple of days. So let's just surrender and go back. Hogan is a word? I thought it was a name. I don't like proper names in my library. Define Hogan. A Navajo lodge covered with earth. Or a United States golfer who won many major golf tournaments in the 1900s. There you go. Learn something new every day. I guess it is a word and not necessarily a name. So we surrendered, we go back. We've been adding the settings. At the start of this week, we basically had screen size and VSync. We added a button. Well, no, this was on. Button was also in there. So all those animations where things move and change colors, we can turn those off for like the speedrunners and people that don't want to be distracted. You can set the colors for the letters. So red for reject, green for accept. You can change those if you're colorblind. That set of characters where I hit the X and all those characters were just turned to red, that's this list. So if you were to start with a different start, like if we start with bread point flush, it's again 15 unique characters, but the X actually needs to not have B in it, it needs C, and instead of F, I think it's H that goes away. No, not H. Anyways, there's basically a 2-letter difference between starting with these word letters and starting with prime lunch toads. So you should be able to go into settings and set your list of characters that you want to reject depending on what kind of logic you're running. So the goal here today is to fix audio. Well, not fix audio, improve audio. Now that we have settings for changing the audio, the volume, one, the sounds aren't well balanced between each other. Two, we need to save some more information in the embedded audio we make. So let's see here. I guess, just explain what we're doing. We go into our source folder and we look at something like Sound Warehouse. I don't know why I'm doing it that way. Sound Warehouse. Yeah, it's 20 megabytes of text. Because we have some different functions for looking at the data, but each sound has its binary data actually encoded in this file, so it's compiled directly into our executable. So if you go to builds release version -l, right now the whole program is 11 megabytes. I'm trying to keep that down. I have some ideas for compressing my audio and images, which we will do at the end, towards the end of the project. But for now, I'm just adding sounds to it, and we need a little bit more information for each sound. That make sense? I'm happy to answer any questions on topics related to this project, programming in general, life, universe, everything. So feel free to pipe in anytime you want. We had a nice little discussion about AI yesterday. Ooh, I posted a good quote in my Discord channel, which, if you want to get notifications when I'm going to stream, there's the Discord channel. Also, a really good quote about AI sourced in there recently. Okay. Oh. Why do you use C++ standard library? I only use it sometimes. It depends. If you look at almost all of the game code proper, I hardly ever use built-in containers. It's mostly arrays. I just use statically, or I use arrays that I request. The only times I'm using containers right now is when I do this embedding stuff. So we were in the embed waves file, and I guess I'm only using it for vector right now. The tooling I'm lazy about, but mostly my C++ style is very C-like. Like I'll use the C standard input output over streaming. I just like it better. Also, if I ever decide to downport to C, I'll be mostly there. Int m underscore tags given the entry count. For each entry in the vector of files, we output okay. Files at index dot tag, and this one we want files at index dot Nope, not dot tag. Oh. Okay, so up here where we computed our tag value, wherever that is, tag, oh, func, or we use func. There, those 3 lines, which means they aren't really being used. We'll compute our own tag integer value, modulus d, which will be the tag. Okay, so that's one piece. Oh, oops. Put that in the wrong place. It needs to be up here. There we are. Wow, that was the wrong keystroke. Control C, there we go. And compute the tag. Not tag. Actually, maybe we do two things. Dot key and dot tag as a C string. So that's the entry tags. Then we want to output the volumes table, which is float. Maybe I made it float or double. Volumes. I made it float. Okay, good. All right. Volumes equals all of this stuff. And we don't need the tag name here. It's not the tag, it is files at index dot volume. Up to 0.3f. There we go. Hopefully this embeds all the data we need without crashing anything. And it hates my life. Because I did not put a semicolon. It's a problem when you start copy pasting too fast, you lose track of things. Invalid user defined conversion from lambda. Right source. Oh, that is true because key tag volume then size. Int to float. Oh, that is correct. Right source embed sound function has not been declared. Yes, it has. But it has not. Where's my type def? Oh, there we go. Sound function, there we go. So yeah, just copy pasting, making things compile. Note. Key was not declared in this scope. That's fine because we can get files. So index.key.cstring. File name, oh, Keo, not Keo. Index. Constant tag equals 0. Assignment to read-only variable tag. Why is tag read? Oh, it's because it's const. That's a silly thing. Then we have a copy paste duplication error there. And there. I knew that's going to come up. And const. Okay, a lot of these errors should go away now. I really failed to. That's terrible. Doom, doom, doom. Tag was not declared in this scope. Files sub index dot tag dot c string. Oh yeah. No. Should be sizes sub index, whether there's a comma or not. File index dot tag dot c string or key dot c string. Similar thing here. Actually, we could simplify this. We don't have. This is not a general purpose function like we copy pasted from. So this code will actually never be called. Width and height. From here, this code is never called. I have a more generic version of what I'm doing here that is used for other things, but this is becoming special purpose. We were storing things as just a list of string pairs. So we just need to find like plus equals 2. That's fine. This is fine. This is all reading binary data format. Okay. And then divide by 2. Right like that. Nope. Guess so, I guess. Oh, warning, unused variables, widths and heights. Perfect. Almost there. Multiple definitions of right header. That is correct. don't want common, I want embed waves. So we're going to write sound header, write sound source. Good. What kind of error reporting pattern do you prefer? I don't like exceptions. They have a bad habit of becoming spaghetti code. I like to return an integer code or log an error message and return a default value. It sort of depends on the situation. Like having a dogmatic, here's how you handle errors, doesn't really work, I think. Sometimes getting a default value and continuing is fine. Other times getting an error code and passing it up is far preferable. Okay, so go to, where are we? We're in builds release. 1, 2, 3, tools, bin, /embed waves. Okay, it didn't crash. That's always good. And now if we look at the sound warehouse dot I wish C or C++ had multiple returns, but often if you want to get like the error flag and an output and a return value, then you just have to pass in a reference to your OK variable or your error code variable, which, nah, not my favorite. We reload this and we have get volume defined and get size defined. We have the volumes and sizes buffers, or the tags and volumes rather. Sound warehouse.cpp, and this should all be updated. It's a big file. Yes, thank you. Like I said, I have plans to shrink both the code base and the sound binary embedded data eventually. Use out parameters? I have, yes. I try not to. Most of the time it's better if the return value is something useful, but yeah, if you have to, you use out parameters. So tags, volumes. This is looking promising. If we go way down to the bottom, there are the volumes that we embedded, and there are the tags. So these are, oh, music is 0. Uh-oh. That should be a 1. It kind of doesn't matter. Let's see here, sounds.text, music. Oh, okay. I know what the problem is. There we go. Embed the wave files. Sound warehouse dot. Now when we go down to the tags, this is now a very big file. We've included some things here. Okay. So yes, 1 is our music. Because source, no. When we go to settings, we have the master volume, which will then be multiplied by the music level volume or the sound effects level volume. So a sound needs to know which factor to multiply by, if any. If there's none, then it won't multiply anything. So that's why we're storing that tag in our embedded data. Okay, so with that being said, we do not need to keep soundwarehouse.cpp open because it's a big file. And then we'll run our own compile, make -k clean debug, and see if the sounds got all that new data correctly. Or if it, let's just see if it builds. Then we'll update the sound class to read out the tag and the volume when it loads the sound. So what's everybody else's projects? Anything good? Non-codes, I've seen you before. I've seen non-code streams before. I've seen TCAP streams before. Seems like a pretty good little community here. I'm pretty new. I'm not really a Twitch person or a content. I don't consider myself a content creator. I consider myself more of just a programmer who happens to stream. So let me know if I create any, or if I perpetrate any Twitch faux pas or anything. Okay. The only test we have is, does it still run? It does. We haven't broken anything yet. Okay. So now we hook up our new sound warehouse to our sound class. We have tags. So we need to define our tag. Tag. And the volume is already coming in as a float. So in sound.cpp, where we go to the warehouse, here, we get the index, we get our PCM data. So for those who are not into audio, PCM is pulse code modulated data. We're reading in signed 16-bit integers as our audio data. So when I go to compress later, I'll probably do a mu-law encoding, which reduces each sound sample to 1 byte instead of 2 bytes. And it has to be a logarithmic curve. You can't just do divide by whatever. It doesn't capture the audio well. A mu-law encoding does a much better job, and that's actually is usually embedded as a lookup table instead of actually doing any logarithms. So that's one way we'll shrink our data and our code eventually. Here, PCM sample count, we have to know how many sound samples there are. We set the duration, which is good. So the last thing, two things we need to do is get signal data.tag equals sound warehouse dot get tag, which will return an integer. We have to cast it to our sound tag. Now we'll have a tag when we look up our volume. And then we're actually going to take our default volume from the sound warehouse as well. Get our volume at that index. I don't think set volume does anything interesting. Oh, it does. This clamps it. So maybe we should instead of just setting it directly, just call set volume. Let it clamps it correctly. And that should do it. So all of the sounds should now. Oh, so we're reading in our volume and we're reading in our tag. But we're not applying that tag data yet. Let's just read it in. Oh. All right. So right now we're manually setting the volumes because the click sound needs to be louder than the other sounds. So we are overriding whatever we read in. So these sounds are going to be really, really loud for now. So when we get there, I'll tell you to watch your headphones. I'm writing firmware for an anime waifu body pillow that can talk to you. That that is interesting. I did not expect that response. So I assume you already have the waifu body pillow. You just need the talking part. So you're adding speakers and a small embedded. What are you doing on like a Raspberry Pi or Arduino? What else is there? Gum sticks. Oh, I have several. Yeah, that sounds about right. Very good. Very good. So as this builds, we're just going to make sure the sounds play, and I'm going to warn you to turn down your headphones. But then we'll have to normalize our sounds relative to each other. Okay, so watch your ears. I don't know how loud this is going to be. Okay, kind of loud. So in theory, these are all volume 1. Which sounds fine. No sounds on those. No sounds on that. Interesting. I'm trying to remember what other things I had sounds attached to. Okay. Well, that sounds kind of loud. I guess the error sound is going to be a loud one too. Double characters. Ooh, yep, that's loud. Okay, so let's plug in our master volume and our tagged volume. Because we now have enough data to do that. In here, towards the very bottom, here's where we multiply by the sounds volume, which was loaded in based on the warehouse. There's a glitch at the end of the sound waves. Yes, there is. We spent almost 5 hours already looking for it. It's near the. It's on my list of tasks to fix. Sound fix audio click at end of sounds. A lot of the things that they tell you to check for, I checked for. So like, they want you to taper the sound down to 0 before you hit the end of the data buffer. I verified that that was 100% true. Like the sound was at 0, and then actually filled a whole other buffer full of zeros. That didn't fix it. Yeah, I checked a whole bunch of things. We spent a bit of time on the forums, and I've pushed it off to the background for now. That's for as much time as I've put into it and been able to find the issue, makes me mad. So yes, I agree, 100%. So here, data volume. Let's compute a float volume equals data volume sound dot h. We need the game context. And what we're going to do is switch data point to tag. Case sound tag sfx volume times equals game context master volume. Actually, we can just add that here. Volume times equals sfx volume. Get our music in here. The default is to do nothing. I guess sound effects was first. Music was, no, music was one, wasn't it? I don't have to, but default, let's do nothing. How did you learn audio engineering? I never did. Are you using a library for sound? Yes, yes. So I'm using port audio. That's my, those are my, what, 4 or 5 dependencies. Port audio. So one of these days, I will definitely revisit that. How did you learn audio engineering? I never did. This is a first for me. Actually, this level of OpenGL and game stuff is a first for me. Like I took a graphics class when I was in college, and then I never touched OpenGL again. Like back then, it was you had to call GL begin and GL end for it to do anything. It was that long ago, so I'm kind of like relearning OpenGL. That's why I'm keeping the game itself simple while I learn all the underlying stuff again, or for the first time. Audio engineering, yeah. Yeah, I just what I've read and more recently in learning how to do this stuff. So the volume now should be computed every data buffer, which is 256 samples, which in a 41,000 hertz sampling rate should put us in only a couple of milliseconds. So when you hit the volume button, it should update really quickly. Okay, so back to, actually, we're gonna go to the about scene, set volume. We're gonna disable, we don't care about the sine waves. We don't care, okay, so we're setting all of them to something very quiet. And then we're sometimes writing something a little bit louder. So we're going to, actually all of these sounds are not in use either. So what we're gonna do is we're gonna go figure out which one is the quietest sound, and that'll be set to 1 in our sounds.txt file. So whichever one of these is the quietest will be 1. And then we're gonna play 2 sounds at a time and try to make them equally loud or quiet. In the about scene, let's see, I think it's the letters on update, recorded sounds, A, yeah. A through O. I use the about scene right now because I'm not doing anything with it as like my sandbox. So there's a lot of junk in there that, oops. I rebuilt in the wrong directory, so the wrong make file fired off. It only takes a few more seconds than the regular build, but that's all right. Oof, we're in a time slot competing with Pirate Software. Isn't he the game developer from like Blizzard? Port audio seemed like a low-level audio library. Kind of want to do some audio stuff with WAS API and Pipewire, but haven't got there yet. Yep. Like I said, my goal in this has sort of been to strip back all the layers as much as I can, but not use Windows APIs. So if I ever want to port to Mac or Linux, I'm close, like I'm working in a Ming W and a MSys2 kind of environment. So it won't be hard for me to port things. So if I hit A key, that's a sound. Ooh, gosh, headphones. Headphones check. Watch your ears. I have all these dialed all the way up. So, sorry. So that one's very loud. I'm going to protect one of my ears. Ooh, gosh. That's very loud. There's got to be a safer way to do this. If I turn down my computer audio settings, does that make it quieter for you people? Okay, loud sound. That doesn't sound as bad to me. So is that terrible for you folks? All my sound is, sorry. All my sound is not mono, but if I look at the data streams, so I went and compared the left and the right, they could be mono. So when I end up binary packing all this data as small as I can, that's probably going to be one of the things I do is make it all mono. Very bad. Yes, sorry. All right, so I turned down my system volume, so it shouldn't be quite as loud. So here's a loud setting. And this one's feels louder. So if we go to settings and we turn down the master volume to like half, oh. Okay, not quite plumbed in all the way yet. Because master volume divided by 10. Divided by 10. There we go. You know what though? We can actually compute this volume once at this top before we enter the loop. And then we can just use it down here. Volume. Okay. Boom, boom, boom. For some reason, music volume. There we go. Can you change just the display capture game sound volume on OBS? Oh, that's a good idea. See, this is me being new to streaming. I can. Let's see. We go to yes, so I can do that. I'm going to turn my system sound volume up a bit again. So that I can hear how loud things are, and then I'll turn down the OBS when I run this. So we're going to run it. No sounds should be playing. OBS. All right. So I've got it down a lot. We're going to go into about. We're going to play the first sound. Okay. How's that? When you change the master volume, does it change the volume mixing on the OS UI? When you change the master volume, does it change the volume mixing on the OS UI? So the master volume will affect every sound no matter what the tag is, and then the tag is an additional multiplier on top of that. That master volume does not change at the computer, at the system level on the computer, no. I'm just using it locally. Maybe too low. Try it again just to check the loud one. Okay. So here's audio check 2. That doesn't sound too bad to me. How does that sound on from the OBS side of things? Actually, you know what? I could just turn on my audio. Right, retrying the second sound. Okay, so OBS maybe turned down too much. Making it a little louder, trying again. Okay. So that's fine. Okay. So in theory, we can now test these pretty quickly. So A, B. So C is really quiet, but I don't think I'm using it anywhere. What was the list of sounds I am using? Okay, anyway. So D is my second click. That is pretty quiet. E, I don't think I use anywhere. You know what we could do? We could just figure out what noises I'm actually using and skip the rest. Grep.wav in exclude directory dependencies. Excluded. Oh, come on. I've done this recently. .wav. Let's see what we get. I also probably should ignore the .get. But this is the about scene where we use all the sounds. So in the game scene, all we are using, and I'm gonna write this down. There's no point in us comparing sounds that I'm not using anymore. Like I basically loaded all the sounds in just to see what they were all like. So click 2. We're using chime 1. Error 4. Error 2. We're using win 1. Whoosh 1 and whoosh 2. I don't see any other sounds. There's the sound warehouse, etc. Okay, so I think that's it. We only have 1, 2, 3, 4, 7 sounds to fight against, which we can look up the key that they're bound to. So click 1 or click 2 is at index 3. Chime 1 is at index 1. Error 4 is index 10. Error 2, index 8. Win 1 is 11. Whoosh 1 and 2, 13 and 14. Not the shader warehouse. We want the about scene. There we are. So yeah. Click 2 is 3. Chime 1 is 1. Okay. So if we go back to about scene. Chime 1 is B. Click 2 is D. K for error 4. 8 is I. 11 is L. 13 and 14 are N and O. Okay, so now we can test in a more constrained fashion. about. Time to go. Hey, Rizoma, thanks for coming. Always feel free to drop in again, give a follow, join the Discord, whatever. Good to always have somebody here. Appreciate you helping me try to find some audio balance in my stream. I never can tell quite what's coming out the other end here. Okay, so B and D. D is very quiet, so that's probably going to be our number one. Okay, so D is very, very quiet. This probably has to be our 1.0. K. K is an error sound. I. See, K and I sound reasonably similar. L. L seems a little bit on the loud side. N and O sound similar. Do they sound similar enough to K? Yeah, I think the whooshes and the air sounds both sound enough similar in volume. So the win and the chime seem a little loud. L and B seem a little on the loud side. And click just has to be all the way up. So the question is, how quiet does chime have to be to sound like click 2? So if we get click 2 in our heads, then we have the master volume, and go to chime. Is it half? Maybe more. So going back in here, the click 2, which is the quiet one we have to compare against. Nope. Settings. We're going to 10. And then about. There's the click, as loud as I can make it. And the chime, we're going to try maybe like 0.3. And the loud one is B. That actually sounds pretty good. So chime around a 3. And win, which was L. You know, that's probably good. And then we have the errors. So K and I would argue that I sounds a little bit quiet compared to K. So let's make I a little bit louder. Settings for, oops. Settings I. It would go louder on that. 6. I. That might be 0.6. And then that compared to K. K feels a little loud at 0.6. 4. K. We could try that. The whooshes N and O. Those actually sound pretty good at 0.4. 0.4, 0.4. So in theory, we go to sounds.txt. And we take take chime 1 and make it 0.3. We take click 2 and make that our 1. Error 4. Let's see here, which one's error 4 gets 0.4. And we may stop embedding the sounds we're not using. Error 2 gets 0.6. Basically, these are the default incoming starting values without me having to set them, so at least we're balanced. Error 2.6. The win, number 1, is at 0.3. The whoosh 1 and whoosh 2 are both 0.4. I'm just going to hard code something for music right now. So we're not using beat 1, we're not using click 1, or 3, 4, or 5. We're not using error 1 or error 3. We're not using win 2. So now it's pretty easy to see from here. Sort lines. Now it's pretty easy to see which is our reference sound. So chime doesn't need a letter anymore. Click doesn't need a letter. Error 1 and 2. Song win doesn't need a letter. Whoosh 1 and 2. Okay, so I think that's going to clean up a lot, except one issue is in our about scene, we're not using all these sounds anymore. We are using 1, 2, 3, 4, 5, 6, 7, 8 sounds now. We're just going to make a quick refactor around our recorded sounds. We need 1, 2, 3, 4, 5, 6, 7, 8. 8 sounds. We are not setting volume for any of them. We're letting the volumes themselves take care of it. So beep is gone. Chime. Click. Lots of clicks go away. We get an error 1 and 2. We have just win and 2 whooshes. And then we can add the song in. Three, 4, 5, 6, 7, 8. Okay, so there's that one. Recorded sounds. We only need to get through 8 of these. 9? 9. So these all go away. So we're going to fundamentally change our sound warehouse by quite a bit. We'll do a full clean, I guess. So we're changing our embedded data. So yeah, if anyone else has any questions, let me know. So where we're headed? Where are we headed? Our sounds come in roughly with the same or comparable volume level. Then here we apply the different volume settings, the master volume, and then we tagged volume if you have one. So like you can turn on the music and listen to the sound effects a little more, or vice versa. But sound volume is not linear. So when you say 0.1 to 0.2 to 0.3 to 0.4 to 0.5 to 0.6 to 0.7 to 0.8 to 0.9 to 1, it does not sound linearly to your ear. So if we leave all this alone and we just change the master volume one step at a time, it will not sound like a nice linear progression from 0 to 10 or 0 to 1. So we got to take this step. We're going to compute our volume to adjust volume to a linearly sounding level. Because the human ear does not respond linearly to sound. So first we're going to check if just reading them in, so our sound, oh, nah, what? I changed everything. Sound warehouse expression I is not equal to the end. So we did not find this file I was looking for in settings. That makes sense actually. These sounds names have changed. So instead of click 2, it's just click. Where are we at? 4 o'clock. All right, still got time. Oh, I did a clean. Why would I do a clean? So yeah, in the end, the code can be shrunk quite a bit with the embedded binary data because right now I'm using backslash and then 3 octal digits, but everything that looks like an ASCII character, we can just print just the ASCII character into that string buffer. So that's going to save us, 4 characters per ASCII value, which should be a good number of them. Another thing we can do is some of the characters have known backslash escape sequences. Like instead of tab, it would be backslash t, or if a value happens to equal a new line, it's backslash n. So certain characters are going to have the number of bytes or number of characters they need inside of our embedded data. All right, so run this. Settings. So we go to about, and oh shoot, I can't hear B. There's C. Okay, so we clearly have some issues with the way we remapped things. Okay, problem 1. 0, 1, 2, 3, 4, 5, 6, 7. So that's problem 1. 0, 1, 2, 3, 4, 5, 6. 0 through 7. So I can go away. Minus 12 decibels is half right. The only thing I know. I've looked up decibels before. And I know it's a logarithmic scale, but I don't remember the right number. Minus 6 dB. Okay, good to know. Right now I'm just going off of like human ear perception, I guess. Maybe if I was clever and measured things. So A is not playing a sound. B, C, D, E, F, G, H, I. Nope, just H. So B is the only one playing right now. Let's go look up our sound warehouse. Hey, we saved ourselves 3 megabytes of text data. Chime, click, error 1, error 2, song, win, whoosh 1, whoosh 2. So, chime, click, error 1, error 2, song, win, whoosh, whoosh. So these should be finding data. There's the chime. So data is there. What are the embedded volumes looking like? 0.3, 1, 0.6, 0.4, 0.5, 0.3, 0.4, 0.4. I mean, that looks about right, I guess. Chime, click, error, error, song, win, whoosh, whoosh. So why are none of them playing? With every 6.02 decibels, the sound pressure doubles, or with the sound pressure actually halves. It's a sound pressure thing, not about human ear perception. Gotcha, gotcha. Are you an audio engineer then? Or is this just an on the spur of the moment, a good old fashioned Wikipedia dive? Okay, one thing we can do. Oh dear. Wait a second. No. All right, one thing we can do. Set volume to 1. Now they'll all be really loud and not the levels we were hoping to get. Not even close. That's good. You can't learn new things if you're an expert in everything. So there it is, very loud. There's the click. Okay, so the sounds are playing if we make them loud. But I could swear in here that we had sound levels. So it could be that we're not getting them correctly. 0.6, 0.4, 0.5, 0.3, 0.4, 0.4. We will manually set them to the levels that we should have gotten out of our sound warehouse. That's not ideal, but it does tell us that the problem lies in the way we're getting our volume data out of the sound warehouse. Okay. So that actually sounded reasonably balanced. So what it means is our sounds are getting their volumes out of the sound warehouse. Right. Set volume, get volume. Sound warehouse. Oh, I did not update this piece right here. It's returning an integer, not a float. Get volume should return a float. Because m underscore volumes is an array of floats. Build embed wabs. Oh, target equals build wabs. There we go. File. There we go. Star shell cd tools bin embed wabs. So this should now show float. There we are. Now we can build debug. I don't think I need to do it clean. I guess in the about scene we should remove the manual volume setting. And it should just start up with the right volumes. Oops. Okay, and about. They should just work. Little loud. It does not sound like they've been applied. Okay. Playing key A, sound name at volume. Okay, so we can make this easy. Search for that. 0.3f. There we go. We will print out what the volume was set to. I should be getting it when we load this file, but that's not what we're getting. Nope, they're not being scaled. Okay, so go to sound. Set volume, sound warehouse, get volume at the index. This file is literally all the way down to the bottom. There are the volumes. None of them are 1 or 0 except for click. Get volume returns m volumes at index. So I think that looks right. Set volume clamps it if it has to, which it shouldn't have to, and then set signal data volume to volume. We call set volume at other times. Nope. All right, let's see if that prints out then. It's in the code, but I've had other times where GCC for some reason just won't execute a line of code. Okay, so there's the 0.31, 0.64. Okay, so those are all looks right. So if we go, see now it took it. I don't know why that line didn't compile in. That always makes me mad. It's been there a while, but it wasn't taking effect. So about. Okay, those all sound reasonably well balanced. So that's problem 1. Let's go to our journal. We should save this work. Today, tag sounds on scaled volume per sound in embed sounds. Yes, each sound has a tag now, and the volume is volume set when we load the sound from the warehouse. The sound warehouse. Okay. I have applied volume controls to the sounds. Sounds volume changes based on the master volume. Tagged volume is untested so far. Git status. We've been in sounds.txt correct journal about scene. Yep. Games. Oh, the game scene. We have broken the game scene. Guaranteed. In all of these wave file names, click 2, chime, error 2, error 1, win, whoosh 1, whoosh 2. That should fix it. We should probably test it real quick though. So anybody else in the chat, an audio engineer, gonna tell me all the tools that oh dang it, re-embedded all the data. All the tools I should use or techniques I should be using. So I started having an inkling about some of my current development philosophies years ago. I was reading a GDC paper on this guy that's like one of the great audio engineers. And he said, when we're making our first game, back in whenever that was, the 80s probably, he was like, the game studio didn't have a sound engineer. And they're like, well, hey, you go make sounds. So he did. He made his own little sound engine and it was terrible. But in making it, he learned what he didn't know and he learned what he should do better. So the second game came around, they're like, well, you're our sound expert. And he got to rebuild his engine again from basically from the way he wanted, because nobody else knew what he was doing, but he did. And the second engine was better, and by the third game, like, he was the audio expert, right? So that's kind of my philosophy in software development. When you want to build something, if you want to do it well, you write it 3 times. The first time is you learning the shape of the problem. The second time is you making improvements, and the third time is refinement. Now, you don't necessarily have to rebuild entire projects that way, but like, don't be afraid to refactor. If you build something and you're like, oh, I could do it better with this now that I know how it works, go do that. I mean, that's part of becoming an expert in something. All right. I think that's everything. Mid-M. Sound settings, or master volume applies to sounds, tags, and default volume set on sound load from sound warehouse. Oh, we should do that. Okay. Boom. Saved our work. Yay. Now we're safe again. Now we can make wild, crazy changes. Okay, so the other thing we need to test is the tagged volume. So we have the song versus the sound effects. So we need to check to make sure that those 2 volume levels behave as we expect. Then we need to see if we can linearize a volume setting. Half an hour left to go. All right. So, in our game, Whoosh works. I don't remember now if game scene loads audio or does its own volume thing. Game scene. What's here? About scene. Set volume. That's not what I want. Set volume. There we are. Game scene should no longer have to do that. Set volume. Good. So that all goes away. Awesome. What about setting the scene? Set volume? Oh, I do. Okay. All right. Now, to test tagged volume controls. Oh, did I do it clean? No, I didn't. Good. So what we're going to do is go to settings. I want to crank music way down and leave sound effects really high. When we go to the about scene, H is the song. Seems pretty quiet. And the chime is still quite loud. Honestly, the song is not as quiet as I would have thought. So if we go here and make music full blast, and the sound effects nice and quiet, what does that do? The chime is considerably quieter, and the song is considerably louder. Okay, so those are working. That is tested now. Okay, so the last thing to do to linearize our volume steps. And I don't know what a good way to do that is other than to try lots of permutations. So let me think. All right, we can cheat. Let's just go to About Scene. Let's add some keyboard controls in here. So that's the animation testing. Where's my audio testing? Here it is, H. Let's make I and K B game context set master volume to +1. So that goes up, and this one will go down. We hit I and K. Game context master volume. Okay, so that's one IKOL, I guess. I'm already pretty sure I'm using the arrow keys for something else, so that's a problem with the sandbox. IKO and L. Instead of this, we're going to say ×2 and divide by 2. We're just going to get a feel for how different audio curves sound like. Oh, that's not quite right, is it? Nope. Because we want our master volume, we want our volumes to be ±1. This is the linear part. So if we change the master volume, that's a float. I think it takes integers. So we're going to go to About Scene and use I and K to test. So I set volume 0, K set volume 0. Well, that's awkward. Set master volume, clamp, etc. Return master volume. IK. Okay. Floats, not integers. Normally I try to wrap up about 5 o'clock local time, but I started late today, so probably can go longer. 10, 9, 8, 7, 6. Okay, so let's go to 10 and listen to chime, 9, 8, 7, 6, 5. So does 5 sound half as loud as 10? Okay. 4, 3, 2, 1. Actually, that behaved shockingly well. That behaved shockingly well. Maybe because it's already multiplied by a scaled value that we like. So if we go to 10, we put dial back the music, sound effect stuff nice and loud. See, that music sounds really loud. Not really loud, but at 5, which means that at 10 it's going to be even louder. Although I did not sound normalize the song at all. So maybe that's something I should do so we can compare apples to apples. Okay. About scene. Oops. Song. Set volume to 1. So we said 5. So we go to about. We were playing it by default at a volume of 5. Let's try 3 as compared to a chime or a click. That 3 still seems really loud. Oh, no. Let's go chime at full blast. And then song. Yeah, so song is probably a 0.3. Maybe 0.2, 0.25. Sound warehouse. I don't like manually editing these, but we will because I need that half, I think. Song 0.25. Oops. Okay. So maybe my sound linearization was always a problem of the initial volume of the sound not being set to something reasonable, and then the scaling didn't sound correct. Or not good enough. I don't feel like the song completely drowned out the click at all. And that's kind of a loud song anyways, like not one we're going to actually use in the game in the end. It's just the one that I know doesn't have any copyright on it because my sister wrote it for me. Okay. So when we play, a lot of our sounds Should be okay. So if we make these assumptions, these things have to be true. BD. Oh, interesting. B is in and Y is not. To Tibet. There we go. Tibet. Nope, not Tibet. I can't. B tip. Verbs. So if we'd kept doing our logic through here, we might have got there probably with this one. Those are all gone. Those are all gone. R has to be in. P has to be out. B has to be in. Yeah, we would have got to verbs if we actually kept going. But that's fine. Sounded reasonable. So do I need to worry about linearizing the sounds? I don't think so. Let's go to journal. Minor cleanup around sounds. When starting with a, I'm going to call it normalized, even though it's not normalized, volume per sound, the integer volume steps sounded reasonable. So I don't think we need to do that step, which is good. So we got our cleanup done, git status, git add, git commit, minor cleanup. Oh, no, we can't do that yet. We need to go to our sounds.text. The song used to be a 2.5. We probably should run it again. Tool bin / embed waves. Oh, the sounds warehouse did get a small change. Oh no, yeah. The changes were manually applied, but then the generated the same thing. Minor cleanup. Really nothing there. Okay. So last thing is right now settings are not being saved when we start and stop the game. So the settings are changed every time. Hey Brian, welcome aboard, stranger. How's it going? ¿Cómo você está? So the settings to store include window position, window size, colors, reject characters, volumes, vsync, and what's the other thing we need? We want it to be done by the application. Animations. Sync on off. Volumes, reject chars, colors, window size, window position. Sync animations. I think that's it. I'm fine. I'm learning compilers in practice. Yes. Tried executing my Java program outside the IDE. Ooh, scary times. The IDE can hide from you a lot of things that you should know. Some error like cannot find text at, yep, relative paths. So one thing I said before is when you first start out, like, don't use an IDE because the IDE hides things from you, so you don't really know what's going on with every single step. And it's more important when you're starting out to learn what's going on than it is important to generate a product or to create a working thing. And then obviously as you learn things, then you start using more and more tools to hide away the parts that are boring. But like I think beginners are in too big of a hurry to produce at production rates and not to learn. I'm not saying you shouldn't use an IDE. I'm saying you should learn what the IDE is trying to do for you, so there are fewer surprises. I assume there are several ways to get around to that, like reading the manuals on what the IDE is trying to do, looking at all the IDE settings can show you what directories it's looking for and how it's trying to run things. Looking at the IDE's output terminal when you run it, that can often tell you where resources are that it's pointing to. So there are ways to get there, but I think if people just start from absolutely nothing. No, I did not use an IDE when I started programming. We had to submit our programs via terminal to a particular server on the university campus. So I would write all the code I could at home. I'd use the Bloodshed compiler, which you couldn't really call an IDE by today's standards. Like it literally just type your code in here. Yeah, in a notebook. I have notebooks full of my notes from college still. So you'd type it all up, you'd make it work on your local machine using anything, which, yeah, back then it was the Bloodshed compiler, which basically just compiled, so it wasn't much of an IDE. And then you'd take it into the school, you'd SSH it, you'd SCP it over to the terminal, on the terminal to the server, and then you'd compile it and find out that they're using a different compiler altogether, so you'd fix your bugs there through the terminal, which is why I learned Emacs. You need to learn either Emacs or Vim, didn't matter which one, but that's when I learned Emacs, because I had to edit code through the terminal. And then you could submit your program. So, done a code exam using paper and pen? Yes. Yes, code exams with paper and pen, always fun. Yeah. So, there was one class in particular, systems programming. We had to do something in Perl. So on the test, it was implement this thing in Perl. So I wrote out my little function, I handed it in, and I got it back, and I got like 5 points out of 15 on this question. And I was like, what the heck? So I typed it in on my computer and ran it, and sure enough, it ran. So I brought it to the teacher. I was like, this program runs, and it does what the question requires. And he's like, oh, it does? And of course, the problem with Perl is it's a write-only language. So when he looked at my code, he did not understand what it was trying to do and assumed that it was a 5 out of 10, 5 out of 15 kind of answer, when my answer was completely correct and ran in the machine. So he gave me my credit back, but it was clear he didn't care about the class. He didn't care enough to learn the material. He got into arguments with the students about whether the TCP protocol operated at the TCP network layer. It was unbelievable. But yes, writing code on paper, that was a common thing. Most teachers, like in C, C++, if you're writing a C program on paper, they don't really mark you down for semicolons and function names not matching with the standard libraries, that kind of thing. But they were more interested in, did you do the thinking? Do you know how it works? Would you have got the right function name if you had an IDE to work with, etc., etc. So yeah, fun times. I think these are all the settings we need. Let's just look one more time real quick at settings. Animations, vsync, colors, reject characters, screen size, volume. Did I write volume down? Window position, window size, colors, reject characters, volumes, vsync, and animations. Okay. Now, if I'm not mistaken, a lot of that lives in game context. We have the colors. Oh, play mode. Selected play mode. Colors. Preset rejects. Volumes. This does not have vsync. That's part of the window. So let's line these up by type of thing. Window, window size. Vsync is a function of the window. Selected play mode is done by, and these things are run by the game context. I think that's what we need to know. So if we go to application, oops, source, application. When we init, we do have the window, so that's good. So basically, we're going to initialize our game context here, scene manager, etc., etc. We could probably load settings here, execute main loop cleanup. We need to clean up before the main window does. I think that's it. I'll try to bundle the dependency in the jar or in the target folder. Yep. Yeah. Development environments have gotten ridiculously complicated. I'm trying to simplify everything just to make file. Nothing fancy. Just a compiler on the command line. Nothing fancy. If I write a script, it's for myself. Like, I'm not using any tools that I haven't built myself or come with a standard like GCC kind of environment. Okay. So I think we know where we're going to coding, and I know where we're going to be, what we're going to be doing. The two questions are, do I want to do a binary save file, or do I want to do a text-based save file? You guys debate that while I go on a restroom run here. Okay, I am back. So chat, tell me, should we do a binary file or a text file? I'm leaning towards binary myself. I try to respect my users' disk space, computer resources, etc. And I can always pack my binary data much, much smaller than a readable format. Um, static const char star config file. We are going to need C string, C standard IO. We are going to need C standard lib. I think that's it. Don't be tough on yourself. Nah, binary is easy. Anybody can do binary. Okay. Application config file equals word sleuth.cfg. Seems good. Logger in here. I do log note. Code in binary. Yes. It will not be human readable. It will not be friendly to the human eye. It is not as scary as some people assume. So we should see something about loading config, application load config, and when we quit, there's several ways we can quit, but we'll do the X. It should save the config. Okay. All right. I think we're good to go then. So from the journal, these are the things we need to save. And we do have a copy of the main window here. We do also have a copy of the renderer or frame width. So vsync. So I don't actually have a function for calling vsync. Really? Only inside the handler. Interesting. Okay, well, we're going to need that information. Tool is vsync enabled. Void set vsync enabled. Wow, I kind of thought we had something like this. That is after resizable. Oh, it's in the renderer. Okay. Now I'm curious what I was doing in the renderer. Actually, that makes sense. Is vsync enabled? Set vsync enabled, which is called by the window. Oh, interesting. There's a better way to do this. Setting scene, vsync, set callback vsync. Clicked. This one. We just do that. So that's one thing we need to do. Okay, back to window then. Get geometry. I really want the position here, X and Y. Because I'm going to use the renderer. Oh well. So here's one of the cases where we're going to. Have you ever worked in a game studio? It's okay. Game studio proper, no. What I've done is worked in immersive training simulators. For a long time, it was a like a buzzword to call them serious games. We used Unity. We had input controllers that was basically an entire bucket seat out of a combine harvester or out of a planter or out of the hardware horizontal directional drill. And so we had all those weird inputs coming in off the CAN bus through USB into Unity 3D, where we rendered everything and simulated the equipment to be as close to realistic as possible. So if you count serious games, whatever that is, then yes. Otherwise, no, not a real game studio, no. I'm just a programmer. I'm actually kind of a generalist. Like, I haven't done one type of programming for so long that I'm only good at that or that I'm really good at that. What I am is good at a little bit of everything, I guess you could say. Um, so, like, I've done bare metal, no operating system microcontrollers. I've done embedded systems on like a Raspberry Pi and a Gumsticks. I've done web development. I've done robotics. I've done, uh, a lot of desktop application stuff with either Qt or Java. I've done virtual reality. I've done wireless sensor networks. We've done desktop applications for a lot of different projects, including crowd simulation or for like standards compliance, document authoring for testing aircraft, military aircraft aircraft. Yeah, so just a lot of different stuff. But game studio, it's debatable. I would argue no, personally. but I also don't want to downplay that I have used like Unity for years. Not recently, but I have used Unity for years and know what it is, what it does, and sort of how to put games together in general. Cool. Yeah, that's one of the reasons I like software. But in the modern world, it seems like everybody only wants to hire specialists. We want 6 years of just React. I'm like, who cares? Who cares if you've used it before? You should be able to read the docs, fiddle around with it, and get it to work. Like that's part of the deal, right? Once you've learned your first dozen languages, it doesn't matter anymore. In fact, after you learn the first 2 or 3 programming languages, it doesn't matter anymore, I think. So, unfortunate the world is going that way. Okay, geometry, renderer, frame width, and frame height. These are things we're going to want to store. Window position, window size, vsync on off. Okay, I think we have enough to do the Windows stuff. So let's do this. Is that after renderer init? It is. And it's after the window has started up. Before the scene manager started up, so that's good. Yeah, I think this is a good place to put it all. Okay, so first one, let's get the window geometry. Int win x, win y, win width, win height. We don't care about the width and the height of the window. We only care about the render size. Bool vsync enabled equals renderer is vsync enabled. This is going to come down into load config somewhere. Oh, interesting. We may need to make changes to this very function here, get geometry. Then we have the frame width and the frame height. Okay. So we have all the data we need for a window. Now all we need is a file and to do things with it. Sorry, I gotta check. So when I initialize this, I tell it whether the size is with respect to the render area or the full window area with the decorators. Init window. Set geometry. Oh, gosh. Yep, I'm already sad. Okay. I think we need to make changes to set geometry to accept a size mode. Tell me whether it's a window or a renderer based width and height. That would simplify things quite a bit. Which actually means that this would kind of go away. But we don't have to do that right now. Okay. First thing we need to do is get, let me look up the C standard lib C++. There should be a get env. There it is. Retrieve the C string containing the environment request variables to an internal memory block whose content orbitally may be altered by further calls to get environment. Shall not be modified by the program. Perfect. Okay. So const char star user directory equals get env. I think it's usually an app data. Then we're going to make a char star file name equal so we need a strlen pfg file len equals this user dir len equals strlen of user dir file name equals a new character array of size config file length plus the user directory length plus 2 question mark. But we will s print f file name should get modulus s slash modulus s, which is the user dir and the config file. Okay, let's print that out to see how close we are. Log note. Config file. Output file. Okay. This is going to be user dir. This is going to be application config file, and this will be file name. Let's see if we can not blow things up. Oh. I copied the whole function prototype. Isn't that cute? Let's fix this. Oop, fat fingered. 2, 3, 4. No. That does not look like it blew up. Now we see what pops out when we quit. User directory, app data roaming, Sleuth config, out file. Of course, Windows has to be stupid. You know what we can do? We can actually fix that. For char star c in equals file name c not equal to the null character plus c, and that has to be contents of c. If the contents of c equals a backslash, the contents of C should equal a /. See how that goes. And when we quit, hey, they're all forward-facing slashes. Go us. Now, this is something we're going to use twice. One in the save and one in the load. So let's make that a function. Static const char star git config file name. Return file name. Ooh, you know what? We want to make a directory. Do we want to make a directory? We kind of do. Let's see here. Make dir. So where's make dir defined? C++ make dir. Is it standard lib? I guess we could have looked. Nope. C++. Let's search for make dir. Make dir. Oh. Where's make dir defined? That's just rude. Probably, let's see your types. CF environment, C float, C int types, locale math, set jump, signal, standard arg, standard bool, standard definition, standard int, standard IO. Would it be in standard IO? I doubt it. Nope. C create directory. Oh, good old Unisted. Okay, here's the code we need. Stat make dir. Do I need types? That's the file name. I see stat types. I'm not sure why this person's using types. Here's the code for it. Whoa. So stat says, does this exist? I'm not sure I need types defined. We'll try and just do that. Victor, only in file system or use OS API. Yes, OS API. Yeah, so it's in the C libraries. Where are we at? 5:20. Where am I at? If I go much longer than 5 hours, it becomes hard to upload my videos. So yeah, for those interested, I do upload my videos to YouTube and Rumble. So Twitch chucks your VODs after 14 days. Maybe that changes when you make affiliate or partner or something. I'm not there yet. So if you want to see where we started 3.5 weeks ago, that's the place to go. You can watch them on double speed or with the sound down, just to get an idea of how far we've come in 3.5 weeks. Because we have a problem. We're going to save multiple files into this app data. We're going to save our config. We're going to save a high scores file. Is that true? We could put the high scores inside the config file. I kind of don't want to. So we'll need a high scores file. And then we're going to also store playbacks of the high scores and the latest run. So we need to make a directory. So I'm going to get the user directory. We're going to make our application directory. Application. Let's get another const char star here. App name. And we're going to squash those two together. After going to be equal to a new character of config file length plus app name length plus 2. Let's print f to after directory when. We're going to use this again in a minute anyways. Modulus s of app name of the user dir. There we go. User dir and the app name. Then we can use stat. Oh man, sorry for my stupid question. What question? Always open for stupid questions. Questions are good. We're going to zero fill as stat. Then we're going to look for our application directory. If it doesn't exist, we will make this directory. Probably like 0777. Read, write, execute permissions in the directory. Char star argv and char star argv array. Yep. They are technically the same. One is described as a pointer to an array of arrays, and the other was a pointer to an array of pointers to arrays, but ultimately they end up being the same thing. For myself, I like the pointer to a pointer. I don't know why. I like the char star star argv better. Okay, now file name is equal to the after length plus the config file length. Plus 2. Oh yeah. We can flip all these characters in here. Okay, so we're going to mooch together after and our config file. Then we should not have to do this actually. And then return the file here. In this function, file name needs to be deleted. Yeah, the bracket parameter is like something they shouldn't have done with. Provides no more safety, no more utility than a pointer. Yeah, I mean, if they distinguished between a pointer to an object and an array, that would be nice syntactically, but this is C we're talking about. Old days, yeah, I mean, I kind of see why. Sometimes it's nice to, well, so for example, here where I'm walking forward through the characters of a string, like I'm using a pointer C to index into an array, which is actually another char star. So like there's definitely some mixed types in here of an array versus a pointer to a scalar inside of that array. Yeah, it could get a little messy. I think I just did a build, so this should quit. Okay. Load config, blah, blah, blah. application save config. User directory is there. The config file. I don't feel like I did the thing I wanted to yet. I mean, we can't just log everything right before we return. Log note. User dir. After. Then the results should come back. Plus user dir length. That should help. Semicolon. Yes, there should be a semicolon. I agree. Oh. Okay, I do not want this to be constant. Also, I have to write to it, so that makes sense. Missing initializer. That 0 should fill everything. Because that's the thing. Too many arguments to function makedir. Oh, interesting. Really? I do not get to pass in on this system folder permissions. Curious. I will be curious to see then. What we get. Okay, create a directory. Oh, yeah. Save config. We created the directory, which has not been /repaired. User directory, app directory does have word sleuth, and then there's my config file. Okay. So close. You know what? The only place that we have to do this at all is right. Oh, no, we don't want to do that. Nope. This memory was given to us by a system that still owns this user dir. We can't free or do anything with it. We do need to clean up our app dir, though. And then we are returning. So the two news are app dir and file name. We return file name, we delete the app dir. Okay, so for each character in app dir, we flip it. If it's a backslash. We should build that though. Compile, build. WTF. I don't know. I don't know what you're talking about. Did I lose track of something? C's pointer syntax leaves some definite ambiguities. So the directory exists because we created it last time. User dir, app dir, and that's all forward facing, saving to. Good. The file, this directory now exists. And we have a file name. So this can all go away. F out. equals f open our file name. We are reading it in binary. If f out equals null, then we know something is wrong. Could not save config. Otherwise, we can now do things to it. We're going to get our X and Y position. Okay, so X and Y, even if you have a very large monitor, what, like 8K? What's an 8K monitor look like these days? argv1 and the contents of argv plus 1 is really the same. Yes, that is correct. So here's how I think about it. Let's get a scratch buffer. argv points to an array of character pointers. Okay, and each of these character pointers is itself a block of character memory, right? So if you take argv sub 1, that means not the 0th element, but the first element. It returns this guy, right? So if we had, executable, this is an array of characters, outdir, and Fred, right? argv1 would yield outdir, so the pointer to the second character array. The same thing if you have pointer arithmetic. argv is a pointer. Plus 1 literally means take this pointer and move it forward by the size of 1 of whatever type it is. So in this case, it's a character pointer. So advance this character pointer from 0 offset, this is 0 offset, to the offset of 1. So this is a new different pointer. Then you can dereference a pointer, and that's the same thing. That also yields out directory. Yep, an array index, this subscript here, literally is translated by the computer to be this. Actually, when we say plus 1, the computer already figures out how big that pointer and memory size is. So if you had an array of large objects, it would advance by the size of that object. Since this is a pointer, it advances by the size of one pointer. So when we say plus 1, it means one of whatever I'm pointing to. So always fun. So we get the win X, we get the win Y. And then we are going to F right. F. Oh, no. All right. If I did the contents of argv minus 1, then you will be pointing at memory you don't control. And you will probably segfault if you're on any decent modern operating system. It'll say, you did not ask for that memory. Now, what you could do, let's go back to the scratch buffer. If you had a different buffer, let's say int array, right? Equals 1, 2, 3, whatever. We can have a pointer called index or iterator, right? Iterator equal to array, so it's pointing at this 0th element plus 1. So it would be pointing at this index 2, right? Now we can do iterator equals iter minus 1, and that would move it from pointing at this element to this element. So as long as you stay within these bounds, your OS will be fine with it. If you go outside of those bounds, then yeah, strange things can happen. With the guy with the C pointer master, can he manipulate the memory of others' programs? Yeah, you there. Yes. So a lot of vulnerabilities are buffer overflow, where if a boundary is not being checked, like if you're not making sure that this pointer is actually pointing to something inside of a real array that we own, you can write over the boundary of that array into other memory that you don't own. And then when the program returns from a function that did that buffer overrun, you will have memory that should not have been there, and the computer can execute a jump or execute arbitrary code and do all kinds of very bad things. What am I doing here? I'm looking up fwrite because the syntax is we take a buffer, we take a size, a count, and then a stream. Oh, void star. Yeah, so it can be any type. Size, count, and it has to be. The address of when x, size of when x, count is 1. Written to f out. I think that's how that works. Size of size to the file. Okay, then we'll write when y. And we'll do the same thing with frame width and frame height. Address of renderer, frame width, renderer, frame height. Pretty sure those are integers. Renderer, frame width and height are ints. Good. So frame width, frame height. Is vsync enabled? Let's just write it like we have. Oops. There we go. Bool vsync equals. So this returns a temporary. We don't want to take an address of a temporary. So instead, we'll just return the address of vsync as captured above, size of vsync. One of those. That should basically be all of the window information written out. F close, F out. Let's see what's going on. This information is a relief for my security feeling. You likely need elevated permissions to access otherwise unrelated process memory if you are not a hacker, of course. Yeah, so I mean, that's kind of where the hackers start, is understanding memory and how to work around it. So, for example, just because you make a variable private inside of your class does not mean that someone else using your API can't access that memory. It is trivial. It's only there as a compilation guard and not a runtime guard. So declaring something const or private is no guarantee that someone else is not going to come abuse the system. Those are trivial to work around. And learning to think like that is exactly where you start. Okay, so we've got all that. Load config. We're going to get the file name. We would like to ask if it exists. So I think that's back to this stat. We also have to delete our file name when we load. Could not find file. I mean, this is not an issue at all, like it's not an error case. File name. Otherwise, let's open a file called file in and make sure it's even going to work. We're going to, oops, that's an R above that. Why is that an R? That's a right. W. Binary. Read binary. Otherwise, we do things. We're just going to read the whole buffer, the whole file in, and close it. Then we'll work off that buffer. Oh, which we did somewhere else. Where did we do that? Let's do it in VV. Oh, source file. F open. This is the part I want. Make a buffer. So what we're doing is we get a file handle back from the from the system. This is from the library. This is a library level call, not a system level call. We say, is it a real file handle? Then we say, take us to the end of the file. Tell us how many bytes we're offset from the start of the file. Then go back to the beginning. Now that we know the size of the file, we can allocate a buffer, so just a block of memory, and then we can read it. Now that we have a buffer to put it in, and put it all in our thing, and then we can assert that the size that we asked for matches the number of bytes that the file actually read. Okay. Then we can fclose. Let's see here. Where do I fclose here? Close results, blah, blah, blah. Sure. There we go. This is an actual error if we can't open a file to save our config. These are not errors if we can't find or open it. Okay, go to the other file, make sure that we read all the contents. Okay, now that we have all that, we have a buffer. And we know that we need to read 4 integers in a row, and then a Boolean. Well, I mean, we've already read it. That's not the problem. Oops. We've already read the file, it's in the buffer. So somewhere at the bottom of this, we need to delete our buffer. To do. Read values in and apply them. I don't think we'll get to that tonight. I've just about got to wrap this up. Any questions, comments, concerns? If you want, you can give me a follow to get notifications, or I will plug the old Discord if you want to get a notification when I go on. Not a lot of discussion in there, but if we get enough people in there, maybe the discussions will start ramping up. You know, if you have questions, maybe I'll answer them in a stream. Maybe I'll just answer it in the Discord. Kind of depends on what kind of questions are going on there. Okay. So we are going to run this. We're going to run that right out several things. Let's print out some values. It's going to be, we're just going to call this a rectangle of integer, 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 integer. These are going to be things we're expecting. vsync modulus s. Okay. So we expect when x, when y, we expect renderer frame width, renderer frame height, and vsync question mark on or off. So when we look at our memory after we go look at this file, after we write it, we should see something that looks like these values here. Okay. This is going to have to come down here to where we need to apply the values. All right, compile. Let's see how bad we did. F out, probably a capitalization error. Oops. There we go. Load config. All right, so struct stat. There it is. Now it's going to warn me about all that stuff. Oh, more capitalization errors. I've fat fingered something somewhere and it just has persisted. All right, F-O-U-T, F-O-U-T. That should fix it. Many warnings for not initializing my structure the way that they want me to. It's in the standard though. If you initialize with a struct literal with a 0, it fills all fields with 0. It's a 0 initialize shortcut that I don't know why it's warning me. Okay, so when we fire up, we see load file, the directory already exists, and we could not find the word sleuth config file because it has not been written yet. This is the first time it should be written. So we are going to quit, save config, directory exists, saving to, the window is at 1010, 1024 by 768, vsync is off. Now if we go look that up, c:/users/the do/ app data, roaming, word sleuth, config. We'll go to hex mode. Okay, A is 10. That's 4 bytes, so this is all little endian. So A is 10. Let me think. I need to look at a programming calculator real quick. So if it's hexadecimal 00 4 0. And 30. 1024. Oop, not in hex. Decimal. 1024 is 400. Oh, yeah, that makes sense. So if you take this 32-bit integer and you just turn all the bytes around, you get 0000 0400, which is 128. And then 0000 0300 is 768. So we're seeing the values we expect, and then vsync was off, and I guess that writes that as a single byte. So there's one. If we make some changes, so now it should say directory exists, load config. It does not complain about a missing file, so it did read it. If we go to settings and we change the size of screen and we turn vsync on and then quit, we should see very different numbers here. So equals /users, no app data, roaming, word sleuth. We go to hexel mode. Okay, so this is no longer 10. I dragged that window around. I don't know what that pixel value is, but it is where the Windows XY are. So it's 500 in decimal. In hex, 500 is 1280. So that's good. And then 3CO is 960. So this one is 960, and then 1 is on. So for vsync on. So I think we're working. Yeah, 1280 by 960. So that matches. Okay, so we are correctly saving information out. Tomorrow, we will finish up writing and reading settings. And then, gosh, maybe we have lots of things to do. But yes, we're just slowly grinding away at this game. Most of the week, Friday is compiler day, and maybe we'll do like a half day of something else as well, like board game design or something. I didn't get to it last Friday, but a little variety stream on Friday. So until then, thanks for coming. Feel free to drop into the Discord. Feel free to give me a follow. Pop in anytime you like. I love answering questions. And yeah, thanks for coming. I really appreciate all the conversation. Have a good one.